Hello, my name is Evan Kelly and I work at the Hawaii Institute for Geophysics and Planetology, also known as HIGP. I have a background in chemistry with a bachelor's from Trinity University in San Antonio, Texas. A fun fact is that I like to travel and have been to all continents but Australia and Antarctica. First, I would like to thank ARCS for bestowing me with this award, and now let me tell you all briefly about the work I do. I'm currently in my third year pursuing a PhD in planetary science while also working on the SuperCam instrument for the Perseverance rover. My interests in terms of planetary exploration are mainly focused on Mars and Titan. My research is focused on instrument development for planetary exploration missions, where I test, evaluate, and help develop instruments that have the capability to answer science questions that NASA scientists have. The two types of instruments in which my PhD is focused are Raman spectroscopy and NMR, or nuclear magnetic resonance spectroscopy. But due to the time constraints of this video, I will just talk about the Raman side. Raman is the inelastic scattering of light, meaning that the energy put into a molecule is different from the energy coming out. I work on spatial heterodyne Raman spectrometers, also known as SHRS. The SHRS is an interferometer that replaces the mirrors with gratings, combining the dispersive grating spectrometers which are utilized on the Perseverance rover with an interferometer. The way it works is that light enters through the channel on the left and is split 50-50 towards the two gratings, where it is dispersed into individual wavelengths and reflected back towards the beam splitter, where it recombines, creating an interference pattern. This interference pattern is unique to each molecule and is then imaged by a camera and processed into a spectrum. My work has been on a monolithic form of this spectrometer, which allows miniaturization as seen on the left, with the newest variation being about the size of a dime seen on the right. Along with being miniaturized, the monolith makes the spectrometer more robust and eliminates day-to-day variation in the measurements, making the measurements more consistent. Additionally, the SHRS in these formats, when utilized with a certain camera such as a CMOS, which is basically the same type of camera you have on your phones, gives it a massive spectral range in the ballpark of a few microns, meaning that this device can do more than just Raman, including LIBS, VIS, IR, and UV spectroscopy. With its lightweight design of less than 80 grams, it is light enough to be placed on things like helicopters sent to other worlds, similar to the Mars Ingenuity helicopter. Integration into a helicopter would increase the remote sensing distance to however far you could fly the helicopter, with it just landing and then taking a spectrum. Thank you for this award, and I hope you all have a great rest of your days.